Hi guys, today we're going to talk about recursive sequences. We know that in a sequence, a term is expressed as a sub n, which means that the next term that follows a sub n is going to be a sub n plus 1. We were exposed to something like this when we talked about consecutive integers. And we said if you name the first number x, that means that consecutive integer is going to be x plus 1. Since we are talking about terms a sub n, that means that the term that follows a sub n is going to be a sub n plus 1. So if a sequence starts with a sub n, the next term is a sub n plus 1. The one that follows that is going to be a sub n plus 2. And the one that follows that is going to be a sub n plus 3. We can also write this as a function because we said sequences are discrete functions. We can write a sub n as f of n, which means the next term is going to be f of n plus 1. The one that follows that is going to be f of n plus 2. And the one that follows that is going to be f of n plus 3. Now, if we're going to look at the previous terms, that means that if we have f of n, a sub n, the previous term is going to be a sub n minus 1. So if we have a list or a sequence, we know that the first term starts with a sub 1. If we have a sub n, that means the previous term to a sub n is going to be a sub n minus 1. The one previous to that is going to be a sub n minus 2. We can also write this as a function. We know that the first term is a f of 1, and a sub n is f of n. That means the previous term is going to be f of n minus 1, and the one before that is f of n minus 2. And this is what we learned so far. We can write sequences or express sequences as lists, and we're exposed to a lot of lists in the previous lessons. An example is A357. Or we can express a sequence explicitly by the nth term rule. Nth term rule. Today, we're going to learn how to express sequences recursively. That means we're going to use consecutive terms or previous terms. Let's take a look at the first example. A sequence is defined recursively by a sub n equals a sub n minus 1 plus 5, and the first term is 3. So let's analyze this rule. This is a sub n. A sub n minus 1 means the previous term plus 5. Now let's find the first 4 terms. The first term is given to us, which is 3. Now we need to find the next one. Based on the rule, I have a sub 2. I'm going to switch n with 2 to find the term. A sub 2 equals a sub 2 minus 1 plus 5. Now I know that 2 minus 1 is 1, so I'm going to end up with a sub 2 equals a sub 1 plus 5. That means that I need to add 5 to the first term, which is 3. So a sub 1 is 3, 3 plus 5 is 8. So the second term is 8. Now the third term is going to be a sub 3 minus 1 plus 5. I know that 3 minus 1 is 2, so a sub 2 plus 5. That means I need to add 5 to the second term, which is 8. In this case, it's going to be 5 plus 8, which is 13. And now the last term, a sub 4 is equal to a sub 4 minus 1 plus 5. I know that 4 minus 1 is 3. That means I need to add 5 to the third term. The third term is 13 plus 5. That means 18. And that's the fourth term. So looking at the sequence, what I'm doing is I'm adding 5 to the previous number to get to the next number. That means that this sequence is an arithmetic sequence. It has the first term as 3, and the common difference is 5. So an arithmetic sequence can be expressed recursively. Now let's take a look at the next example. We have a sub n equals 3 times a sub n minus 1, and the first term is 1. I'm trying to find the first 4 terms. Now, the first term is given to me, which is 1. Now, the second term, that means I'm going to have to substitute 2 for n, is going to be 3 times a sub 2 minus 1. 2 minus 1 is 1, so I'm going to end up with a sub 2 equals 3a sub 1. A sub 1 is the first term. The first term is 1. So I'm going to have 3 times 1, which is 3. So the second term is 3. Now, the third term is n equals 3. That means I'm going to have to switch n with 3. This means that I'm going to end up with a sub 3 equals 3 times a sub 3 minus 1, which is 2. That means I'm multiplying the second term by 3. The second term is 3, and 3 times 3 is 9. So the third term is 9. Now, the fourth term, n equals 4. That means I'm going to have to switch n with 4, end up with a sub 4 equals 3 times a sub 4 minus 1. 4 minus 1 is 3. That means a sub 4 equals 3 times the third term. That means I'm going to have to multiply 3 by the third term, which is 9. And that means the fourth term is 27. So in this sequence, I'm multiplying 3 by the previous term. So going from one term to the next, I'm multiplying by 3. That means this is a geometric sequence, where a sub 1 equals 1 and r is equal to 3. So this is what we learned so far. Arithmetic sequences can be expressed recursively. we have to identify the first term when we express the sequence recursively. And then we have to find f of n, and f of n is always expressed in term of the previous or the next term. So in here I have the previous term plus the common difference. Or a sub n equals a sub n minus 1 plus the common difference. And this common difference can be positive or negative. The same thing with geometric sequences. We can express it as a function. We have to mention what the first term is. And f of n is going to be the previous term times the common ratio. Or a sub n equals the previous term, which is a sub n minus 1, times r, which is the common ratio. It can be an integer or a fraction. Now it's your turn. Look at these examples. Look at the recursive formula. Identify the first 4 terms and determine if each sequence is an arithmetic sequence or a geometric sequence. Now let's see how you did. Looking at the first example, we have a sub n equals a sub n minus 1 minus 3, and the first term is 12. The first term is 12. I can see that this follows the arithmetic sequence recursive rule because I have the term is the previous term minus 3. That means all I need to do is to subtract 3, the common difference from each number, to go from one term to the next. 12 minus 3 is 9. 9 minus 3 is 6. And 6 minus 3 is 3. Or I can find each term by following the recursive rule. The second term is going to be a sub n minus 1, which is 2 minus 1, which is 1, minus 3. That means that the second term is 12 minus 3, which means I'm going to end up with 9. The third term is going to be a sub n minus 1, which is 3 minus 1. That's 2 minus 3. That means that the third term is the second term, which is 9, minus 3. The third term is 9 minus 3, which is 6. And the fourth term is going to be a sub 4 minus 1, which is 3 minus 3. That means the fourth term is 6 minus 3, which is 3. And these are the exact number that we got when we just looked at the sequence and identified that it's an arithmetic sequence. For B, I have a sub n equals negative 5 times a sub n minus 1, and the first term is 2. This means that a sub n is equal to negative 5 times the previous term. So this means this is a geometric sequence. The first term is given to us, which is 2. Because it's a geometric sequence, that means r is negative 5. So that means to go from one term to the next, I'm going to have to multiply each term by negative 5. 2 times negative 5 is negative 10. Negative 10 times negative 5 is 50. 50 times negative 5 is negative 250. I can also just follow the rule. The second term is equal to negative 5 times a sub n minus 1, that means 2 minus 1, which is 1. That means the second term is negative 5 times the first term, which is 2, and the answer is negative 10. Third term is going to be negative 5 times a sub 2 minus 3 minus 1, which is 2. That means the third term is negative 5 times the second term, which is negative 10. This means the third term is equal to 50. The fourth term is equal to negative 5 times a sub 4 minus 1, which is 3. That means the fourth term is negative 5 times 50. And the answer is negative 250.